Hi everyone, once again welcome back to our class. Now we are going to discuss about some numerical problems based on the kinematic equations of motion. Now these problems previous JEE mains and Neet problems, very important. Recently ఇచ్చినటువంటి questions. So first of all listen here. Problem is there here. First problem. This problem IIT JEE mains 2021 recent problem given to JEE mains and NEET. Okay, the problem is here. A bus accelerates from rest at a constant acceleration, constant rate here alpha, a constant rate of alpha for some time, after which it decelerates at a constant rate here, for example beta, to come to rest finally if the total time elapsed is t, the total time elapsed here t seconds. Evaluate here these problems. Two questions given there. So one is here, the maximum velocity achieved, the maximum velocity here achieved, this one first one, and second one B, the total distance traveled graphically, the total distance traveled graphically. This problem here, this problem graphical method and also straight line. Second ikkada discuss about the two methods here. First method here graphical method, second method here very simple. So now discuss about the two methods. First method here graphical method. So first method here we are discuss about graphical method. Once again, a bus accelerates from rest at a constant rate alpha for some time, after which it decelerates at a constant rate here beta to come to rest if the total time elapsed here t is t. Evaluate here, find out the two values here, maximum velocity achieved and the total distance traveled graphically. So this is now question is to maximum velocity and here total time question marks. These are two question marks. So first of all graph the VT graph, velocity time graph gives the here acceleration. The velocity time graph gives a straight line. The straight line gives here acceleration of the particle. Now graph is here. Graph. Now this is a graph here. Okay, velocity, this one here velocity, and this is a time, x-axis here time, y-axis here velocity. So starting from, for example 0, this O is a origin, positive direction, acceleration is alpha rate, here rate is a alpha, acceleration is a alpha. To reach the point A, for example, to reach the point here, for example A point, the bus at maximum velocity at A point, after that decelerates to come to rest after some time. This time here for example time taken t1, this time taken here t1, here velocity, maximum velocity v. Okay, this alpha is a positive, OA is a positive slope. So velocity time graph, this gives here straight line, this straight line gives here acceleration of the bus, so this is slope is a positive. So next A to B, this one here gives here deceleration, the body to come to rest at point B. The time taken to reach the point B, for example here this is a t2. So AB is a negative slope, this gives here retardation or deceleration or acceleration. So this is a beta, this one here beta. So here is two slopes here there. So one is OA is a positive, here AB is a negative. Here AB gives here deceleration and AOA is a slope is a acceleration. This alpha and beta both are in constant acceleration and deceleration. So T1 and T2, the time taken to the reach A, the time taken to the reach B, point B. Okay. Now the maximum velocity at point to here A, this is a maximum velocity. A point is a maximum velocity. Here T1, T2. Here T1 is the acceleration of the bus. T2 be the here deceleration of the bus. So T1, T2. Now alpha is uniform acceleration and beta means uniform here deceleration. These are graphs. So velocity time graphs is here straight line. This is a graph. This one here graph. Okay. Time taken as here x-axis, velocity taken as here y-axis. Now here T1 and T2 times of acceleration and deceleration. Okay, deceleration of the bus. Next here V means V maximum means here maximum velocity of the bus. Maximum, this means here maximum velocity of the bus Next here alpha and beta, these are here acceleration and deceleration. These are acceleration and here deceleration. Okay, T1, T2 times of bus, right? Okay, these are times taken by the correct. Okay, saripode em లేదు పర్వాలేదు. Okay, acceleration, deceleration. So alpha and beta, these are here acceleration and deceleration. Okay, next here first of all the time taken, the total time of the bus travel so total time here T is equal to, for example, T1 plus here T2. T is equal to here T1 plus T2. Now first of all the positive OA slope gives here acceleration of the bus. So from the VT graph, now here first of all alpha is equal to here slope of acceleration, alpha nothing but acceleration of the bus, that is equal to slope of simply OA is equal to here maximum velocity by time. Here time is here T1, time is here C1. That means here alpha is equal to V maximum by here T1. So simplifies here T1 is equal to V maximum by here alpha. This is equation 1. This is a positive slope. This one here positive slope. Once again, alpha is equal to slope of AB is a straight line. AB is a straight line. So simple ration slope of OA, that is equal to, according to graph, so velocity time graph, velocity by time, that is equal to alpha is equal to maximum velocity by time. So time is equal to maximum velocity by acceleration, positive acceleration. Next here deceleration, a beta is equal to slope of here line, for example AB is equal to here maximum velocity by here time t2, time here t2 from A to B. So this is a deceleration, this one here deceleration, that is equal to here simply beta is equal to maximum acceleration by here t2, that is t2 is equal to maximum velocity by here beta, maximum velocity by here beta. This is a equation 2, this one here equation 2. Okay, so t1 is equal to maximum velocity by alpha, t2 is equal to maximum velocity by beta. So the total time of the bus, the total time of journey in the bus, that is equal to here total time, that is equal to here t is equal to t1 plus t2. So note this one first of all. Okay, now total journey, the time taken by the total journey, t is equal to t1 plus t2, t1 plus here t2, that is equal to the maximum velocity we want here, maximum velocity of the bus here. Now total time is equal to here t is equal to t1 plus t2. So equation 1 and 2 substituting in this equation. So here t is equal to, that t nothing but the total time is equal to t1 is equal to here formula v maximum by alpha plus t2 is equal to v maximum by here beta, v maximum by beta, that is equal to here v maximum is a constant, maximum velocity is here constant, that means here common term. So 1 by alpha plus here 1 by beta, 1 by alpha base 1 by beta. So this is an LCM. After we will get here t is equal to v maximum into alpha plus beta by here alpha beta. This is a total time, this one here only for total time. So next here total time, maximum velocity, therefore maximum velocity of bus, here v maximum is equal to t into just cross multiplication alpha beta by here alpha plus beta. This is a first answer, this one here first answer. Next one here total displacement. The total displacement is equal to here, that is equal to the velocity time graph. From the velocity time graph, the total displacement is here gives here just to area under the curve, ante that means here area under OAB. The displacement is equal to from the graph velocity time graph. Okay, displacement is equal to here area under the triangle OAB. Okay, note this one first of all. So maximum velocity is equal, we want maximum velocity is equal to here t into alpha beta by alpha plus beta alpha. So this is a maximum velocity, t into alpha plus beta by alpha beta. This is a maximum velocity. Next displacement is equal to now area under here, area under the VT graph, here displacement is equal to here displacement is equal to area under the VT graph, VT nothing but velocity time graph, VT graph. Okay, VT graph. Now that is equal to VT graph, that is equal to here displacement here, for example S is equal to area under, that is equal to area triangle OAB. So OAB nothing but this is a triangle. Now that is equal to here displacement is equal to area, that means is equal to here 1/2 base into here height, base into height. Okay, Now here 1 by 2 base nothing but here OB, and height nothing but here maximum velocity. This is a maximum velocity. Here that is equal, this is a height, that in OA, this is a OA is equal to here maximum velocity. So that means here maximum velocity, that is equal to 1 by 2. OA nothing but here T. So this is a T1 plus T2, that is equal to here T is equal to T1 plus T2. This is a total time, this one here total time. So T into maximum velocity, T into maximum velocity. So from equation 1, this is a equation, for example 1. So equation 1 substituting in this equation. So here displacement simplifies. Here S is equal to, displacement is equal to 1 by 2 T into here maximum velocity nothing but here T into alpha plus beta by alpha beta. Okay, T into alpha plus beta by alpha beta. This is a 1. Next simplifies here displacement of the bus is S is equal to 1 by 2 into T into 2 T square into here alpha plus beta by alpha beta. This is the total displacement of the bus, total displacement of the in journey of the bus. S is equal to 1 by 2 T square into here T square into alpha plus beta by alpha beta. This is a graphical method, this one here graphical method. Next, for example, the bus moving along the straight line. This process, second process here, this one first process only for this one here displacement is equal to T square alpha plus beta by 2 alpha beta. Very important question, this one here, very most important in TS JEE mains and Neet. Okay, JEE mains and Neet. Okay, note this one first of all. OA positive slope, here AB is a negative slope. AB negative slope gives here deceleration, OA slope positive slope here gives here constant acceleration. Okay, next this process, next process in the same process. Okay, now second method, this is a method 1, this one here method 1. Okay, second method ఎలా ఉంటుందో చూద్దాం, we will try. Next one, second method, the velocity of the bus, for example the body or bus moving along the straight line, with constant acceleration alpha, here time taken, for example t1. Okay, here listen carefully, this one straight line, this is a straight line, bus moving along the straight line, moving along the straight line. This one ending point here, for example B, ending point here B. The body starting from rest, here starting from rest. Okay, that means here 0, starting from here according to problem, starting from rest, moving in the constant acceleration, constant rate alpha, to reach the maximum velocity at point, for example to reach the point C, for example C point, the bus to reach the point C at maximum velocity at point B. Okay, this is a maximum velocity at point C. Here time taken, for example here time taken t1. After some time the bus decelerate, come to rest after some time. Here from C to D, here decelerates, that means here the rate here beta, this is a negative value, this one here alpha, this is a decelerate. From C to B the bus decelerate. Okay, come to rest at point B, so final velocity here V is equal to 0, final velocity here V is equal to 0. Here time taken from C to B, for example here T2, C to B is here T1, this one here T2. Now find the first of all total time. Here total time nothing but here T is equal to T1 plus T2, T is equal to here T is equal to T1 plus T2. Okay, here initial velocity in this case here between AC, initial velocity here u is equal to 0 starting point, that means your rest position. The maximum velocity to reach the point C, so it's C point here, final velocity, this one here final velocity, so v is equal to maximum velocity. So the bus moving along the straight line with constant acceleration alpha. Okay, here in this case here conditions. Now between okay AC here, between here AC, A is equal to here alpha, T is equal to just to T1, and V is equal to V maximum, U is equal to 0, U is equal to 0. Now here formula V is equal to U plus AT, U plus AT. So this values here substituting simply. So V means V maximum is equal to U means 0, A means here alpha, T means here T1, T means here T1. So simplifies V maximum is equal to alpha T1. So alpha T1 is equal to, simplifies here T1 is equal to V maximum by here just to alpha. This is the equation 1. This one is equation 1. Okay. Next here, next between here, between B CB, between here CB. Okay, between CB. So the here in this between, in this case here initial velocity here V maximum, final velocity V is equal to 0. Here acceleration A is equal to minus deceleration, so A is equal to negative values, so minus beta here time taken to reach the point B, so T2. Here final velocity V is equal to 0. Here cases here A is equal to minus beta, here A is equal to minus beta, that means here the body decelerates, so uniform constant, uniform acceleration, so uniform deceleration alpha, A is equal to minus beta, and here T is equal to T2 to reach the point B. So here U is equal to initial velocity here in this, in between here V maximum, and V maximum and final velocity is equal to 0, final velocity is equal to 0 at point B. Now this values here V is equal to U plus AT. Okay, here V means 0 is equal to U means U means here V maximum plus A is equal to minus beta, A is equal to here minus beta, okay, into T is equal to just to T2, so simplifies this, taken left side negative values, negative, so plus into minus beta T2, so here minus cancel, minus here get cancel, remaining simplifies V maximum is equal to just to beta T2, so T2 is equal to simply V maximum by beta, V maximum by beta. This equation 2, okay, the time taken by the bus to reach the point B, final position point to B. Now the total time is equal to, now here total time is equal, T is equal to here T1 plus T2, so here V equations 1 and 2 substituting there, that equation. So total time T is equal to here, T is equal to T1 means V maximum by alpha, V maximum by alpha, plus T2 is here V maximum by maximum velocity, so V maximum by here beta. Maximum velocity is constant, so same terms, so simplifies here V is equal to V maximum 1 by alpha plus 1 by beta. This one multiplication simply simplifies T is equal to V maximum into alpha plus beta by alpha beta, okay, alpha beta. So this is a total time, this one here total time, so total time is equal to here simply total time is equal to V maximum into alpha plus beta by here alpha beta. Now maximum velocity from this equation here, maximum velocity is equal to simply T into alpha beta by alpha plus beta. This is a, now note this one first of all. Simply in between AC, this is a T1, in between CB, that was T2. So total time A from A to B, that is equal to T is equal to, so maximum velocity is equal to T into alpha beta by alpha plus beta. Okay, note this one first of all. Next one, now here maximum velocity formula, maximum velocity here, that means here maximum velocity is equal to here T into alpha plus beta by alpha beta, alpha beta. Okay, this is a. Next, displacement of the total displacement of the bus, that means from A to N, from A to B. A to B మొత్తం total displacement here just S, just here yes. So displacement is equal to, displacement is equal to average velocity here, average velocity, average velocity into time, into time. Okay, that is equal to displacement here, yes, average velocity here A V into here just to here T. So here average velocity is equal to U plus V by 2, V plus V by 2. Okay, average velocity of U, initial velocity plus final velocity by 2, that is equal to here is equal to U plus here maximum velocity. Okay, U plus here V is equal to here maximum velocity by 2 into here just to T. Here in this case U means initial velocity of the bus from at point A. So here initial velocity U is equal to here just to Z. Okay, 0. So 0 plus here maximum velocity by 2 into just here T, simplifies here S is equal to V maximum by 2, V maximum by 2 into T. Okay, into T. Now this is a equation, this equation for example 1, this equation 2. So equation 1 substituting in equation 2, equation 1 substituting in equation అంటే ఒకటో సమీకరణాన్ని రెండులో ప్రతిక్షేపించగా. ఓకే, హియర్ V maximum values here, V maximum is equal to T into alpha plus beta by alpha beta into alpha. So from here, from 1 9 2 we will get here we will get simply displacement of the bus here in journey is equal to V maximum, nothing but this values here T into alpha plus beta by alpha beta into here just to into T. Okay, into T into T square, that is equal to S is equal to here T square into alpha plus beta by 2 alpha beta. This is a second method, this one here second method. Okay, this one here method 2. Okay, this is a method 2. Okay, note this one first of all, very simple, very important, JEE mains and IIT JEE mains and Neet. Okay, next problem continuation, note this one first of all. Next question, see there here, this one very important problem, most important problem IMP. So a rifle bullet losses 1/20th of its velocity, losses 1/20th of its velocity in passing through a plank. Okay, what will be the least number of such that requires to just to stop the bullet, how many planks are required, the bullet is stopped. So here first of all, the bullet velocity of the bullet here, for example initial velocity U, this bullet strike the plank, so the velocity is reduced to 1/20th of initial velocity, 1/20th of its initial velocity. After the bullet is stopped, how many planks are required? Okay, now first one, this for example this is a, okay, X means the length of this plank. Okay, for example just imagination plank. Okay, the bullet is here striking initial velocity U, So after outside here velocity 1 by 20th here initial velocity. This is your final velocity, okay, outside. Only for the one plank, only for one plank. So for one plank here, answer for one plank, formula here formula just for v square minus u square is equal to 2as. Here v square minus u square is equal to 2as. This is a formula. Here indicates initial velocity u is equal to u. Here v is equal to here u minus 1 by 20. 1 by 20, that is equal to 19 by 20 u. Okay, this is a final velocity. This one here final velocity. Next here acceleration just a, and here s is equal to just x. S is equal to here just x. This is a data. Okay, these here values are substituting. Here final velocity means this one 19 u by 20 square. Okay, minus here initial velocity just u is equal to 2a, s is equal to x. S is equal to here x. Okay, this is equation 1. Next, how many planks are required? The bullet is stopped at the number. Okay, here for example these are planks, these are your planks. For example, just imagination, planks, number of planks here, this is a here number of planks, n, this is n, each one here x. So this one, this is a, for example, length, total length here total nx, here total x. So initial velocity, for example here u, at point, for example at point c, the bullet is stopped at point c, and for example stopped. So the final velocity here 0. It's this nx plank, this one here c point is a nx plank. Now here in this case, second case here, initial velocity just u is equal to u, u is equal to u, and here v is equal to final velocity here 0, final velocity here 0. Next here s is equal to nx displacement, this is a displacements, so nx, and here a is equal to simply a is equal to. Next case here for n planks, this one for one plank. Now number of planks for here for number of planks, that means n means here number of planks, the number is for n planks. Now n planks, so formula v square minus u square is equal to 2as. So these data substituting, this data here substituting in this formula. So your final velocity is 0, your initial velocity same, u square is 2a is a constant, so s is equal to here, s is equal to nx, s is equal to here nx. So simply is minus u square is equal to 2axn. Now this is a, we want here number, we want to n values, how many planks are required. Okay, now this equation 2, this one here equation 2. Now note this one first of all. Okay, equation 1, this one here equation 1, this is a equation 2. Okay, equation 2 by 1. So equation 2 by 1, after we will get here number of planks here n. Okay, now simply dividing 2 by 1, dividing here 2 by 1, here dividing 2 by 1, the number of planks here dividing here 2 by 1. So equation 2, this is a equation 2 2axn by n, equation 1 2ax is equal to, this is a negative values minus u square by here, equation 1 by 1, so this is 1 19 u by here 19 u by 20 square minus here just u square, just here u square. Okay, clear. Now equation 2 by 1, after we will get here number of planks n is equal to, okay, number of planks here n is equal to, here negative simplifies 2 get cancel, a get cancel, a x get cancel. So remaining here n is equal to minus u square by, u is common term, here u is a common term, so u common, okay. Here 19 by 20 square minus 1, square minus 1, okay. Here this cancel, u square get cancel, so simplifies, sorry, n is equal to here, n is equal to remaining terms here negative values, here this one positive also. After here negative by minus, here 1 place here 19 by 20 square, okay. Here minus get cancel, minus here get cancel, so simplifies here n is equal to 1 by, this is a LCM, this one here LCM 20 square minus here remaining 19 square by 20 square. So this is a numerator, here denominator, so numerator denominator is a just numerator, that is equal to the number of planks n is equal to, simply here the number of planks, here number of planks n is equal to 20 square by here 20 square minus here remaining 19 square. So this is a 20 into here 20 by 400. Next here this is a here formula a square minus b square formula, this is a a square minus b square formula, that means here a square minus b square is equal to a plus b into here a plus b into a minus b. So this is a value is 20 here, b value is here 19, so 20 plus 19 into 20 plus 19 into here just 20 minus 19, note this one, note this one, 20 minus 9. So the number of planks n is equal to, number of planks here n is equal to, simplifies n is equal to 400 by here 20 plus 19 39 into here 20 minus 1 remaining 1. So simplifies n is equal to 400 by just to 39. So this one is simplifying, after we will get 400 by 39, simplifying after we will get here values, here simplifies n is equal to 10.3 planks, okay. Here so therefore n is equal to 10.3 planks. Now the bullet, finally the bullet shell stop, the bullet shell stop in here 11th plank, okay, 11th plank. This is the answer, okay. Here n is equal to just to 10.3, that is the bullet, here the bullet shall stop in 11th plank. అంటే ఎక్కడ అవుతుంది 11th plank దగ్గర అది stop, rest position కు come to rest, okay, come to rest, okay. Note this one, here answer is, this is the answer. So n is equal to here simply 11th plank, n is equal to here 11th plank. Note this one first of all. Next problem, here see there, here problem is a body covers 100 meters in first 2 seconds, here in first 2 seconds, here t is equal to 2 seconds and 128 centimeters in the next 4 seconds, next year 4 seconds, okay, next year 4 next 4 seconds, the total is equal to 6 seconds, 4 plus 2 seconds, moving with constant acceleration, find the velocity of the body, at the end of 8 seconds, ఇక్కడ ఏంటంటే First of all, this one is starting point. Here A is a starting point. A is a starting point. First 2 seconds here travel distance here. First 2 seconds here, for example, A to B. A to B. This is a 100 meters, 100 centimeters, 100 centimeters. Here first 2 seconds. First 2 seconds. Next here and 128 centimeters in fourth. Next 4 seconds. Next 4 seconds. That is equal to 128 meters. Next 4 minutes here. This is a 128. Okay. Next 6. That is equal to A to, for example, C. 6 seconds. 6. Last 8 seconds. Last 8 seconds means here this is a total 8 seconds. Total 8 seconds. Last 8 seconds. Now find out the here velocity, initial velocity, and find out the velocity and just okay only velocity of the bus or body. Okay. Now first of all, very simple explanation. Example also very simply. Now in first 2 seconds here, in first 2 seconds. Okay. Your formula S is equal to ut plus half at square. So here T is equal to just 2. Here T is equal to just here 2. So here S is equal to 100 centimeter. 100 centimeter above the problem. Now here 100 is equal to U plus here 1 by 2 into A into here T is equal to, so 2 to ja 4. 2 to ja here 4. That is a 2 to ja 4. Just 4. Okay. Just for this equation 1. Equation 1. Next in first 6 seconds, 2 plus 4, that is equal to 6 seconds. Okay. First 6 seconds here T, this is a here is equal to T. Next here displacement S is equal to here 128 meters. 128 centimeters. 128 centimeters. So in this formula here S is equal to ut plus half at square. So here S is equal to 128 is equal to U plus U, nothing but here this is a, this also 2 substitute 2U. This is a, now U T is equal to just here 6U plus 1 by 2 into A. T is equal to 6 ja 36. 6 ja 36. This is the equation 2. Now from equation 1 and 2, from equation 1 and, so terminate the initial velocity of the body. Terminate the initial velocity of the body. After we will get to the acceleration of the constant acceleration of the body. So from equation 1, from equation 2. So terminating here initial velocity. Terminating initial velocity in these 2 equations. So here initial, this here 2U, just here 6U. So multiply above equation 1 3 with 3. Now here that means here equation 3 minus equation 2. Equation 3 into equation here equation 1 into 3 minus 2. Minus 2 second equation. Minus second equation. That means here equation 1 here is equal to, this is a removing, first of all multiplication, this is a here multiply on both sides with 3. So here 300 equation, this is a just 3. So inside simplies here 300 is equal to 6U plus here 3 into 4 12A by 2. This is a equation, for example 1. This one here equation 1. Okay. This is equation 1. Now equation 1 minus equation 2. Equation 1 minus equation 2. So equation 1 minus equation 2. Equation 1 minus equation 2 is nothing but here simply okay 300 minus here 128. 300 minus 128 is equal to here 6U plus 12A by 2 minus this value here is equation 2 6u, okay, plus 12 by 2 a 36 here a, okay. Now in this remaining terms here 300 minus 128 remaining here one step simplies here 6u plus here 6 2 2 ja 2 6 ja 6a minus into plus minus 6u minus into minus minus into plus plus minus into plus here minus, so 1 by 2 6 1 ja 2 1 ja 6 18 ja 6 18, so 18a. Now in this here 6, this is a cancel, 6u positive values, this one here negative values, so remaining terms any one step, any mistake, okay, remaining terms here simply 6u, okay, C38 12, correct, okay. Next one here simply 6a minus 8a, so here minus remaining minus 2a minus remaining here 2a, any mistakes, okay. Minus any terms wrong step 128, okay. Once I check it once again here one step, okay, here just mistake in first 6 seconds, here 6 seconds means here first 2 seconds 100 meters and 4 seconds here 120 centimeters, so 6 seconds nothing but here okay, 6 seconds the displacement distance is here 228, sorry, here 228 centimeters, 228 here centimeters. Second case here, this is one here 228 seconds, 228 centimeters, mistakes, okay. Remaining 2a, this is a 300 minus 228, remaining here 72 minus 72 is equal to minus 2a, 2 1 ja remaining here, this is a cutting a is equal to a is equal to any mistake, okay, 32, sorry, this is one 18, sorry, 18 minus 6 remaining, sorry, here 18 minus 6 12a, so calculation, this one calculating 120, this one 72, so minus this one here minus values, cancel terms here, this 12 1 ja 12 6 ja 12 6 ja, so simplifies your acceleration a is equal to minus 6 meter per second square, so this is the acceleration of the body, this one here acceleration of the, this values here substituting in equation 1, this values here substituting in equation 1. Now this one here acceleration of the body a is equal to minus 6 meter per second, now equation a values here substituting above equation here, for example this equation, okay, here 100 is equal to 2u plus 1 by 2 a 4a, okay, here a is equal to minus 6 meter per second square, so this values here substituting, simply 100 is equal to 2u, we will get here initial velocity of the velocity of the body, so 2u plus 1 by 2 4 into minus 6, okay, here 2 1 ja 2 2 ja, simply 2u plus into minus 6 2 ja 12, 6 2 ja 12, here 100, okay, 100 simplifies 100, this taken left side and plus 12 is equal to 2u, so 112 is equal to 2u, simply u velocity of the body u is equal to 112 by 2, that is equal to values here, u is equal to half of this value here 56, this is a meter per second, 56 meter per second, this therefore initial velocity of the body 56 meter per second. So now find out the your values here. Initial velocity of the body u is equal to 56 meter per second, and acceleration of the body minus 6 negative. This is the negative symbol means here retardation. This is a deceleration. So acceleration of the body is equal to minus 6 meter per second, and initial velocity of the body here u is equal to 56 meter per second. Okay, next problems here, continuation exam, next class continuation. Okay, see it, watch it, this video, share it your friends. Okay, thank you, all the best.